All right, this is a specific key type question. So let me read it, but I've already lost my pen. There it is. A 3 kilogram zinc cannonball has been sitting in the desert all day. The temperature, its temperature is 33 degrees Celsius. Night falls on the desert. A wolf howls. Hold on, we might want to highlight that. There are wolves howling at the moon. And then the temperature falls to a chilling negative 10 degrees Celsius. How much heat will the cannonball release as it cools to air temperature? And then it gives us the heat capacity, which is this right here. All right, so do you guys remember the formula for this? It's going to be Q is equal to mCp times delta T. Okay? So another way to write that is mCp delta T. Oh, I wrote it down twice. The initial temperature subtracted from the final temperature. So let's label some of the things that we need to know. I think the first thing that we need to know is that the mass is equal to 3 kilograms. The next thing we need to know is that T1 is equal to 33 Celsius, and we can leave it as Celsius because Kelvin would be the same difference, really. T2 is equal to negative 10. And then what else do I need? Oh, the heat capacity, CP, is equal to 390. So you just plug this in the formula, guys. 3 kilograms times 390, we'll call this kg. And then this is joule, kilograms. Wait, the kilograms goes on the bottom. Per kilograms Celsius times negative 10 minus 33. So then if you plug that in a calculator, it's about negative 50,300 joules. And remember, we measure energy like or heat as an energy, so it'd be joules. Hey, does that make sense to you guys?
Wait, what happens to the momentum of the car? The momentum of the car goes to the station.